So let us recap quickly what we did in yesterday's session. We started with what is function. So a function f is a set, it is a form set A to set B, which is an assignment to exactly one element of B to each element of A. This is what we discussed in yesterday's session, where we call this as domain and we call this as codomain. The elements uh, which are from codomain who are having pre-images in domain, the set of all those is called as range of the function. Uh, A is having image in codomain and B is having pre-image in domain. This is what we discussed in yesterday's session. Then we had a quick discussion related to, yeah, when we say it is a function, when each element from domain is having unique associated image, that is one and only one associated image in codomain, then we say the given relation is a function. When every element of domain must have unique one and only one associated image in codomain, we say the given relation is function. After that, we started our discussion related to various other types of function. Out of that, the first that we have seen, that is one-to-one, or it is also sometimes called as injective function. So when a function is one-to-one or injective, when if it does not map two distinct elements of domain into the same element of codomain. That means every every element from the codomain, whoever is having pre-images in the domain, they are having unique pre-images. This is what we have discussed in yesterday's session. After that, we also seen some other type of example. Yeah, a function is called onto or surjective if and only if every element B belongs to codomain, there is an element A belongs to domain. That is, when your range is equal to codomain, then we say the function is onto function. Okay. So coming back here, one-to-one function. When it is one-to-one function, when you are having every element, or I can say every element belonging to codomain or range, you can say, is having unique that is one and only one pre-image in domain. That's it. And when it is okay, one-to-one function is also called as injective function. Okay. Similarly, just now we have seen one more type that is called as onto function. So it is also called as sometimes onto function is also called as sometimes surjective function. So when it is called as onto function, when a range of function is equal to codomain, then it is onto function. Fine. There is one more type of function that is called as into function. It is when the function is called into function, if there exists at least one element of B, there is at least one element of codomain which is not having any pre-image in the domain. That means if the range of function f is a proper subset of codomain, then we say the function is codomain. When the range of function f is proper subset of codomain, then we say the function is into. If it is proper subset means what? And there is at least one element in codomain, like here. If you take this function f2, there is at least one element in codomain, like you can take element D, which do not have any pre-image. So the range of this is this, which is proper subset of codomain. If you look at here, this range is proper subset of codomain D. Why? Because the element D and E is not present in, they are belonging to B, but they are not belonging to range. And therefore, if your function is having this property, that is range is proper subset of codomain, then we say the function is into. When your range is equal to function, sorry, range is equal to codomain, then we say the function is onto function. And when it is one to one, when no matter whether it is into or onto, when whatever the elements that you are having in your range, if they do have unique, that is one and only one pre-image in the domain, then we say the function is one to one. So is it clear or not? Please let me know in the chat box. Any difficulty in understanding? Please do reply quickly in chat box. Is it clear or not? Yes or no? Okay, good. Let's proceed ahead. Now, there is another, we say bijective function. When we say the function is bijective function, when it is both, both injective and surjective. When it is both injective and surjective function, then we say it is bijective function. That is, when it is both one-to-one as well as onto function, one-to-one and onto function, then we say it is bijective function. Let me just show you any visualization. So let us take a quick visualization when it is a function and when it is a non-function. It is a function. Why? Because every element is having some associated element in the codomain. So this is a function. This is not a function. Why? Because elements belonging to domain are having two images in the codomain. This is not allowed. So this is not a function. When it is injective function, injective or sometimes it is called one-to-one. When it is one-to-one function, when each element is having unique pre-image in the whatever elements are there in the range, they are having unique pre-image in the domain, then it is injective function. If you look at here, they are having two different pre-images. So this is a function definitely, but this is not injective function because element belonging to codomain is having more than one pre-images. So it is injective. It is not injective, this is injective. Or sometimes injective is also called as one-to-one function. What is meaning of one-to-one? One element from domain is having one image. Similarly, one element from this range is having only one pre-image. That is the meaning of one-to-one function. One element is associated to one element here, and this element is associated only from one element here. So this is one-to-one mapping. This is not happening here for this element because one element from this is belonging to one element here. One element from this is belonging to one element here. But this element is not having only one element associated with this element. There are two elements that are associated here. Therefore, it is not one-to-one. Proceeding ahead, surjective is also called onto. What is onto function? When your entire codomain is equal to the range, then it is onto function. Otherwise, it is into function. And when it is bijective, when you do have one-to-one mapping, means one element is mapped to one element, and similarly, one element from range is having only one unique pre-image in the domain, as well as your range is equal to the codomain. Therefore, it is bijective function. So, hope things are clear. Yeah, let us take the example. Let us say you are having domain is 1 to 3, codomain is ABC, and this is your function f. 1 is mapped to C, 2 is mapped to A, 3 is mapped to B. So let me know whether this function f is bijective or not. Quickly respond in the chat box. Is this function f is bijective?
The screen is not.
Oh, wait. Wait for a moment. Let me connect. Uh, so, yes or no? This is your domain. 1, comma 2, comma 3. This is your codomain A, comma B, comma C. Function f, 1 is mapped to C, B. Is it a bijective function? Yes or no? Yeah, come on, quickly respond now in the chat box. When the function is bijective, when it is one-to-one as well as on-to function, then we say the function is bijective function. So is it one-to-one function? Yeah, good. So yes, it is both one-to-one and on-to. So let us take this example another. Let us say you are having a function from whole set of whole number, W to W, okay? And what is that function? If you take any element from this W set, the mapping is what? G of n is equal to what? Floor of n by 2. That is the floor function. So what is the floor function? Meaning of floor function is what? Okay, let me just write here. I'm not able to draw that symbol. So when you do have a floor function, if I write here 7.2, what does it mean? The floor function returns the lowest possible nearest, the lowest rounded integer. This is floor function. So the answer is 7. If you take the ceiling function of the same, it is the highest rounded integer, that is 8. So this is called floor function, and this is called ceiling function. Okay. If you are having one
Sir,
function,
floor,
yeah,
sir,
yes.
floor function is what it used to be greatest integer value function.
If you give any number to this, the floor of x, that is equal to lowest rounded integer. That means apply here 3.8. The floor function will give what is the lowest possible integer is, what is the highest possible integer is 4. Okay. Anything intermediate value, if you apply here in the floor function, it will always give the floor value. What is the floor value for this? That is 3. If you apply this to ceiling function, what is the ceiling? To the ceiling means topmost, the highest value in this range. That is 4. So that is the interpretation of floor and ceiling. Floor means what is the lowest possible integer rounded, what is the highest possible integer rounded for that particular fractional value. So if the lowest possible rounded integer, it is with when you apply, when it is floor of something, it is the lowest possible integer. When you apply to the ceiling function, it is the highest possible integer, rounded integer. Is it clear?
Yes, sir.
Yeah. So let us proceed ahead. What exactly we are discussing in the given exercise? We are having one function from W to W. This is function f. And what is that function f? If you supply any value which x belongs to W, f of x, that is equal to what? Floor of x by 2. This is what we are discussing at present with respect to this exercise. So this is the function given to you. Okay. So if you just apply 0 is the input. F of x, x is belonging to w. And what is f of x? This is the value, which is also belonging to w. So 0 is mapped to whom? If I take 0 from here, it is mapped to whom? 0 divided by 2 is 0. Floor of 0 is 0. So 0 is mapped to 0. Something like that. Similarly, if I take 1, if I substitute 1 here, 1 divided by 2 0.5, then if I take the floor, that means 1 is mapped to 0. Similarly, 2 is mapped to whom now? Can anybody tell me who is mapped to? Who is mapped to whom now? F of 2, that is equal to what?
1.
1.
3 is mapped to
1.
1. 4 is mapped to
2.
5 is mapped to
2.
2. Okay. So this is just a snapshot. You can take n number of instances. Now coming back to the question, is this function is bijective function? Yes or no? That is what we do.
No, sir.
First of all, let us go step by step. Is it a function? Yes or no? Is this f is a function? Yes or no? Yeah, come on, tell us. Tell me now. Is this f is a function? Yes or no? Let us go step by step. F is a function. Yes or no?
Yes, sir.
Okay. Let us go another way. Is f is a one-to-one function or injective function? When we say one-to-one, that just now we have discussed few minutes before. So is this f is a one-to-one function? Yes or no? Okay. It is not one-to-one. So Chetan, why it is not one-to-one?
Sir, because 1 to 1 means मतलब डोमेन से मतलब 1 to 1 रिलेशन होना चाहिए, तो इधर 0,0 एंड 1,0 भी है सर,
Hmm.
इसकी
So
वजह से.
element 0 belonging to codomain are having more than one pre-images. This is the way you should justify.
Yes.
Okay. So therefore it is not one-to-one. And let us discuss about, is it into function? Is it into function? It is a function, but now we are discussing various types. No, is it into? When the function is into function, when the range of the function f is a proper subset of codomain. So Viraj, you are answering, you are asking. Yes, question mark. What does it mean? Yes, Viraj. Yeah, Viraj, I am asking you. It is into. Okay. So yes, it is into, but it is not onto. Therefore, it is not bijective. Why? Because it should satisfy both property. It should be one to one as well as onto. Therefore, it is not bijective. So let us discuss here. G is a bijection. No, G is onto, but not one to one. Therefore, it is not bijective. Now, bijective function. Yeah, Viraj, you said it is into. Why it is into? Let me understand here. Why you said into?
Because what range is
When you
proper.
say it is into, then it means there is some element in codomain who is not having pre-image in the domain. So you should give one instance to justify this.
Sir, both sets are whole numbers. No, so it
Huh.
is into.
See, when we say a function is into function, when your range of function f is a proper subset of codomain. That means there is at least one element in codomain who is not having pre-image in domain. So when you say it is into function, you should give one counter example.
Three. Three has
3.
yes, sir.
Okay, when you say 3, 3 belonging to codomain, just wipe out this. You are saying now 3 belonging, this is your domain and this is your codomain, WW, and this is your function f. So you are saying element 3 belonging to W set is not having pre-image in W. That is what you are saying. Okay. Is it? Yeah, Viraj, I am asking you.
So no, it will be. No, it is not into.
Yeah, it is onto function because
It is
every
equal
element,
to
it is not equal, you can say. Every element of W is mapped to one of the element in W, and W is infinite set. This is also infinite set. So yes, every element if you pick up here, they are also having pre-images. So if you take 3, what will be the pre-image? You can take any integer starting with 3 point something. You take any integer. So they are mapped to 3.2 if you take. They are mapped to 3. Any infinite number of examples are there which are mapped to 3. So if you take any element x from the codomain, you do definitely have x point something, x point something, x point k you can say in domain. They are mapped to x with this floor function. So definitely this is not into function, this is onto function. Okay? Clear or not, Virat?
yes, sir.
Okay, coming back to example, this we done. Yeah, so there is one theorem. Let f be a function f from domain to codomain where it is from same set to same itself. Where a is infinite, where a is finite, not infinite. Then f is one to one, if and only if f is onto. F is one to one, if and only if f is onto. So let us discuss this with one example. So let us say you are having one set A and this is your another set A, the same set, and you are having element, let us say 1, 2, 3, 4. So domain and codomain both are same, and you do have one function, mapping function A to A, that is f. Okay. So what is this theorem is saying? Let f be a function from domain to codomain, where domain and codomain both are same, and domain and codomain both are finite. It is not infinite. Then f is, if f is one to one, if f is one to one, what we are saying, f is one to one if and only if f is onto function. So if your f is onto function, what is meaning of onto function? That your range is equal to codomain. Range of A is equal to A. Codomain is A. When your range of A is equal to codomain, then it is onto function. So what is meaning of this? When it is a onto function, what does it mean? That every element are associated, every element of this codomain are having pre-image in the domain. So if you take this, when you are having this information, this onto function, what does it mean? That this element, I'm just taking one of the instance. Let us say 1 is related to 2. Means two, not 1 is related to 2. 1 is having pre-imaging domain, that is 2. That is 2 is related to 1. Okay. If you are saying, let us say 3 is also related to 1, fine. Then I may say 1 is related to 3, and I may say 4 is related to 4. So if I take more than one pre-image, when the cardinality of domain and codomain are both are same, then if you do have one element, at least there is one element who is having more than one pre-images. In that case, there is one more element. Is that, let us say if I have some if I try to connect this with this two, so yeah, it will satisfy the onto property. Means what? Range is equal to codomain, but it is hampering now the function definition here. Why? Because one element is having more than two. So this is not possible. So what is this theorem says? That if you do have a function from domain to codomain where the domain codomain both are same, and if you do have, when you say it is a function and one of the properties given to you, it is a onto function, it has to be one to one. It has to be one to one. So how you prove this? When your A is finite and F is one to one, so is F is onto function, so you are just checking vice versa. If you do have a function f and it is onto function, assuming that it is on, sorry, one-to-one function, so we need to check whether it is onto function. So yes, every element points to exactly one element. That is, injection assures that they are different. So we have cardinality of A, that is different elements A points to, that is how many different elements that we are having in codomain. When we say each element is mapped to exactly one element in the codomain. So what is the number of elements that are mapped? What does it mean? When we say it is one-to-one function, what does it mean? That whatever elements, cardinality of A means what, you are having n elements in your domain A. So how many images will be there in codomain? It will be also n. When you say one element is mapped to exactly one element in codomain, so one element is mapped to exactly one element in codomain. So here it is one element is mapped to exactly one element in codomain, as well as in codomain, if you take any element, it is exactly having one pre-image. So your range, if you do have n elements in your domain codomain, it will definitely become onto function because the range and codomain both are same. So that is the meaning. Every element points to exactly one element. Injection assures that they are different. So we do have cardinality of A, that is n number of different elements of A points to, means there are some pre-images. So since F is A to A, that is codomain is covered, thus the function is also onto function. Already you have given one to one and it becomes onto, one to one onto, that is your bijective function. So we are proving this property here. Similarly, if you say f is onto function, then we need to prove it is one to one. Okay. So yes, every element maps to exactly one element and all elements in A are covered. So thus the mapping must be one to one. So going with one to one, you are landing in onto. Going with onto, you are landing in one to one. So that's what exactly we are proving. Basis on this proof, we are proving now that when a function f is from same set to itself, and when the domain codomain both are finite, then this function is one to one if and only if f is onto. What does it what does it mean by this if and only if statement? If and only if means what? If X is the property, it implies Y. And if Y is the property, it implies X. We'll shortly see in logic when we will start this. This is single implication. What does it mean? When this is true, then this is true. When X is true, then Y is true. When Y is true, then X is true. When X is true, Y is true, as well as Y is true, then X is true. Then we say X if and only if Y. That means X is true, then Y is true, as well as when Y is true, X is true. Bidirectional implication. So when X implies Y and Y implies X, we say X is bidirectional with Y. Means X is if and only if Y. Means if X is true, then Y is true, as well as when Y is true, X has to be true. That is the meaning. We'll see this in logic when we start the logic section. That time the things will be clear. So what I will do now, I will shortly come to this function again. So we have already done. Now one more property I need to discuss, that is monotonic increasing and monotonic decreasing function. Let me just check whether it is here. Yeah. So a function f from a to b, where a comma b are subsets of R, is called strictly increasing if for all x comma y belongs to A, such that if x is less than y, f of x is also less than f of y. And when it is decreasing means what? When your x is less than y, f of x is greater than f of y, it is strictly decreasing. And this is strictly increasing. So I will just let you know with some example if I do have here. Yeah, it is not here. So let me talk instead what is meaning of this. So when you do have a function like here from a to b, when you do have some function, and if there are certain x comma, if you take any two element x comma y belonging to domain A, what will be the x is mapped to whom? With the f of x. Suppose there is a function f which maps A to a function f and b. This is the meaning. There is some function f which is mapping from A to b. So what is f of x and what is f of y? F of x is nothing but what? Image of x in codomain. F of x belongs to b. Let me write here, same thing here. Okay. So these are the, if you take any two elements, we are talking about any two elements. If you take any two elements belonging to domain, and we need to observe what is their image in the codomain. Sorry, it is not domain. Codomain. Okay. So we need to observe x is less than y in your domain. If you take any two elements, x and y, such that x is less than y in the domain, you need to observe what is f of x and what is f of y. If you take any two elements belonging to domain such that x is less than y, and for that f of x is also less than f of y in codomain, we are talking. For any two elements which are where x is less than y in domain. If you take f of x and f of y and you observe the relationship, f of x is also is less than f of y, then we say it is strictly increasing function. Which you might have already studied in your function in your college level when you started anything related to transcendental functions. You already studied trigonometric, inverse trigonometric, exponential, logarithmic. I am sure you must have studied this in your elementary college level, strictly increasing function. Okay, and when x is less than y, if you do get f of x for all x less than y, if you do get f of x greater than f of y, always, then you say it is strictly decreasing function. Okay, is it clear or not? Please let me know in the chat box. What is in understanding of strictly increasing and strictly decreasing function? We'll discuss this later on when we will start the algebraic structure, grouping field. That time things will be more clear. On the basis of this increasing decreasing function, there are certain algebraic structures that we need to study. So please let me know whether interpretation of strictly increasing function is clear or not. We say f, what is strictly increasing function? F is strictly increasing function, we say. The name of the function, f is strictly decreasing function. So I received only one response from Gaurav. What about the rest of the students? If it is not understood, please let me know. I will again try to explain you if there is any ambiguity or if you have not understood. Please let me know. Accordingly, I will repeat. So only Gaurav is responding. What about the rest of the students? Please let me know.
Sir, can you explain once?
Okay.
Sir, can you explain increasing and decreasing?
Pardon?
Strictly increasing and decreasing.
Hello.
Strictly increasing and
I'm
decreasing.
not able to hear you. Who is talking? Can you again talk? Let me understand who is talking. Anai. Okay. So please try to understand. Function we have understood. There is no question. When this function, see, is satisfying some characteristics for all the elements of domain. See, when you are having some set, having some numbers, when you do have some set having, let us say, a comma b comma c comma d, where you cannot say that a is small than, lesser than b, b is lesser than. It is when we are talking about numbers. In that case, we are observing some important property. If that property is satisfied for all x comma y, in general you take any two elements x comma y from this domain, if f of x and f of y are also having that property satisfied in codomain, on the basis of that we decide whether the function f is strictly increasing function or strictly decreasing function. So what does it mean? So if I say one, in this case there are certain alphabets, but if you do have, like earlier case we discussed, we do have some W is mapped to W, let us say, or maybe M is mapped to W, or you may take any set, Q is mapped to W, whatever, A is mapped to B, where A and B both are having some numbers, okay? So wherever the domain codomain contains numbers, whether they are same set or they are not same set, whether they are finite or infinite, doesn't matter. What exactly we are talking? You take any two element from this domain. You take any two element, that is x and y. In general, we are talking. Doesn't matter what are the elements here. You take any two element. Let us say I have taken 1 and 2. So in this domain, 1 is less than 2. Okay. So we need to identify what is the mapped element of, so in this 1 is what x and 2 is what y. So 1 is less than 2. Both x and y belonging to domain. Let me just clear the screen. Let us take this is your domain and this is your codomain. So in general, you are having some element x1, x2, x3, x3 dot 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 xn. In general, I'm writing this is your domain and this is your codomain. Let us say this is your domain A, this is your codomain B, and there is a mapping function f. What exactly we are talking? You take any two element, let us say arbitrarily xi, xj, any two elements arbitrarily from this domain, and if such that xi is lesser than xj. So now we just want to observe what is there in codomain with respect to this. So let us say xi, f of xi is x dash of I, and f of xj is xj dash. Something is there in this codomain. So in general, what we are seeing, no, if you take any two x and y, xi, xj from this domain, and if xi is less than xj, you need to observe whether if this is also holding f of xi is also less than f of j, xj in codomain. For all xi, comma xj where xi less than xj, you do get f of xi also less than f of xj in codomain, then we say the function is increasing function. The function is increasing function. What does it mean? Increasing function means what? Yeah, you take 2 less than 3. F of 2 is some number there and f of 3 is some number there. Even you do get this order means if 2 is less than 3 here, f of 2 is also less than f of 3 there in codomain. Then we say it is increasing function. And what about decreasing function? When we say for xi less than xj, if we do get something like this, f of xi is greater than f of xj, that means it is decreasing function. What does it mean by decreasing function? Let me just show you. If I do have here form, yeah. I do not have. Yeah, but let us try to understand a function f whose domain and codomain are subsets of real number is strictly increasing if f of x is greater than f of y whenever x is also greater than y and x and y in the domain of f. Similarly, f is strictly decreasing when it is inversely, like f of x is less than f of y when x is greater than y. You take it is just like you say no directly proportional and indirectly proportional. When it is xi is less than xj, then f of xi is also less than fj, strictly increasing. But if xi is less than xj, f of x is greater than f of xj, then it is opposite, that is strictly decreasing function. We'll see this more when we'll start the algebraic structure. At time being, you just remember when it is lesser here, in domain, if you take any x and y from domain, if x is less than y, then f of x is also less than y. For all x comma y here, if x is less than y, f of x is also less than f of y, then it is strictly increasing. But f of x is greater than f of y for x less than y, then it is strictly decreasing function. That's it. So coming back to where we are. So this we have discussed, already discussed. Yeah. Now the next topic is inverse. An interesting property of bijection is that they have an inverse function. So let us try to understand what is meaning of inverse function. There are two types of function that we need to understand. One is identity function and another is inverse function. So what is meaning of inverse function? You already learned what is relation R and what is the inverse of relation R. In the same way, this is inverse function. The inverse function of bijection A to B, when we say bijection, it is one-to-one and onto function. When you are having a mapping function from A to B, there is an inverse function from B to A. It is what exactly, let us try to understand. When you say it is a number like a domain, let us say 1, 2, 3, 4. Okay, this is a domain, and the codomain is, let us say, 1, 4, 9, 16. These are the elements in the codomain. So 1 is mapped with 1, 2 is mapped with 4, 3 is mapped with 9, 4 is mapped with 6 by some function f. So f of 1 is 1, f of 2 is 4, f of 3 is 9, f of 4 is 16. So what is f inverse? F inverse. Inverse of f. F inverse is another function, mapping function from codomain to domain. So if I say inverse of f is, let us say g. G is a function. So what is g of 1 is 1. What is g of 4 is 2. What is g of 9 is 3. What is g of 16 is 4. So what I'm talking right now, let me just show you visually. This is your domain and this is your codomain. And you do have one function, mapping function from domain to codomain. Let us say this domain is A and codomain is B and mapping function F. Then we say if this mapping function F is a bijective function, it is one-to-one as well as onto function, then there exists a inverse function from codomain to domain, that is F inverse. So we'll discuss this in detail in next session since we already crossed the time. So please post your attendance in the chat box.